Well, YouTube, I had a bad week. One of the things that happened, besides my toilet breaking and overflowing and my bathroom sink faucet breaking and flooding the bathroom, and the drain falling apart on the kitchen sink, and the plasma table breaking down, and the batteries dying in my welding truck, and the air conditioning going out in my car. Besides all those things going on, I also broke my belt sander. I was in the shop getting some stuff off the wall over here because I can store metal up on this wall, and in the process of getting that down I knocked over some other stuff which knocked my belt sander off of this cabinet that it sets on and broke this mount right off. That is not a very strong mount, and I would actually say by looking at this one point right here on this little gusset, this reinforcement rib, that it's actually been cracked for a while and vibrating there. This spot actually has rust in it, so I think there might have been 2 cracks in this mount to begin with. But still, a belt sander really isn't designed to survive a 32-inch fall onto the floor, right? So today I'm going to rebuild this mount. I don't have an exact plan at this moment in time. Right now I'm just going to take all this apart, see if I have some metal that will kind of work and kind of get me back into the realm and dimensions of this thing, and then I'll come up with a plan as to exactly how I'm going to build it and exactly how I'm going to do it. So first step, let's tear all this apart. Just a little note here, these holes are very much oversized for the mounts they go into. That makes this plate adjustable, so I'll have to make sure I do that in my design. Now I gotta figure out how to get these pulleys off of here. Are they going to come? Is that thing bent? Yep, that is definitely a bend right there. It hit the floor and went kerschmack there. I don't use this platen, but most of the time it's actually just in my way, so I'll still try to remove that carefully, but it looks like I don't have to be too careful about it to get it off of there. So I need to figure out, well, they'll come off. I was all worried they'd be really difficult to get off of there, but it'll fall right off anyway. I might be able to put that in the lathe and machine that back down. That might be the easier way to go. And that pulley just slides off, easy peasy. Okay, I was actually dreading getting that all off of there. Okay. Well, that should come off. There we go. That's what that piece looks like. So that piece, this piece on top of it, that is what we are going to build today. Or in this video, because I don't know how many days it'll take me, because I'll probably end up working on a lot of this in my spare time. So what I'm doing right now is working on the dimensions for this vertical part of this. A couple things to note. There is a recessed ring right here that goes around the snap ring. And also the bearing protrudes out of this housing and actually fits in this bore here, although not snugly. There is some play in that, but I need to keep those dimensions in mind. And then instead of doing these grooves that are, you know, allow the table to go from horizontal to vertical infinitely, anywhere in between there, I'm going to do horizontal position, vertical position, 45 degrees, and then I also have some marks on here. I think I put it at 35 if I remember correctly,
instead of 45, because I think that's about 45, so there's about 35, something like that, whatever it is, or 55, depending on which way you look at it. I want another set of holes there for that angle, because that's the angle which I use this, at which I sharpened the blades for the Kindling Maker. So I just need those 4 positions, and no need to have this infinite slot thing going on here. And the other thing is I'm going to use 3/4 inch plate, which is thicker than this. This is actually 0.6. Yeah, so it's just under 5/8. I have no 5/8 plate in stock. I don't ever stock that stuff. I almost never use it. So I'll go ahead and build out a 3/4 inch plate, and we'll probably machine down this circle area to get it a little thinner. And since this has the curve to the outside here, I'm going to cut this out on the plasma table. So I need to go over there and start drawing things, and then we'll cut this out and put in some holes. All right, I'm going to get out my little chunk of 3/4 inch plate that I've got under the table. And of course I'm going to be using the VEVOR chain hoist for this. This chain hoist rocks, and it is very affordably priced, like 1/3 of any other chain hoist I found on the market. And it's working great. Well, normally I do this kind of grinding to clean these edges up over on my sanding cabinet, and ironically use the belt sander, but I can't use the belt sander right now, so I'm going to do it over here on the plasma table. I'm going to put it on my magnetic chuck, try to hold that in place, put a piece of sheet metal over here, and turn on the sucky suck, and just grind it over here on the plasma table. My next step is I'm actually going to mill these ends. There's 2 reasons for doing that. One, I want this piece to look really good. So I want a really good surface finish on all of it. So I'm going to mill pretty much everything and make it look good. The second thing is I want to really square these edges, these ends here, so that when I put it in the vise, it will stay flat and square and not try to pop up, because plasma cuts are slightly tapered. So I'm going to throw this in the vise, and we'll machine off this side, flip it over, and machine off this side. Flip that over. Actually, probably have to deburr that, won't I? Alright, yeah, there's a little bit of burrs on that, so let's see. Flip it over and do it all over again. That edge came out nice. But anyway, now we got to that point. Put it in there. Make sure it's the right length first. Oh, hey, yeah, that'll work. All right, let's figure out how to get that hole, put it in there. So that hole is going to be, that's 1 3/8. Oh, what do I have that's 1 3/8? I don't think I have anything that's 1 3/8. What I'm gonna do is start with 1 1/4 annular cutter. And then we'll put the boring head in and go up to the 1 3/8, I guess. it'll be made out of 3/4 inch plate, and then we'll have to machine down the circle area here so it's thinner and so it matches together good. Okay, I moved the boring bar out to the outside position here, and I'm going to crank the head out. So the boring bar is all the way out there. This is going to be dumb, isn't it? This is going to end in tears. So I was trying to use it as a fly cutter here. Now what I'm going to do is go past 0 on the digital readout up there, that way I know I've gone far enough. Right there. Alright. Well, the next step is to cut this little recess in this housing here. This goes around the snap ring that holds the bearing in place over there. So my thought process was to just set this broken piece on here, kind of line it up with the hole, and then run the boring bar out until it touches this outer ring. We might be the right diameter. So what I'm going to do is set that there. I'm actually going to 0 my quill, and then I'm going to come over and set that there, and that says we're taking 40 thousandths off. So I'm going to do the same thing here, run down to there and 0 the quill again, make sure my headstock is locked, and then we'll just take 40 thousandths off. And that'll give us a good guideline, but I just can't take that deep of a cut at once. Too much for it. So we'll back this off and do it in stages. Alright. Well, that's working now. Okay. Just keep doing this. Where's my outer ring at here? Where are we at? Alright, we might be there. Alright, I got that all nice and machined out. So I've got plenty of clearance for the snap ring that holds that bearing in. And then I was looking at this piece and I said, you know what? I like this machined surface much better than this hot rolled finish that's been sanded. So I'm going to go ahead and take a light skim on the whole rest of this thing as a fly cutter and just kind of make it look a little prettier here. Yeah, that looks awesome. That's a nice finish. I really like that. That was worth it. Next thing I'm going to do is put holes in that piece that's in the mill to match these holes. A little slow for that bit. think that's all the holes I want. Nervous about this. I don't know why, taking a part out of the vise always makes me nervous. It's going to need some deburring on this side, isn't it? A lot of oil on that thing. So overall, the holes are where they should be. Looks like everything came out. So now I am going to put this piece in this side and go ahead and machine this side off because, man, this surface finish looks so good. It'd be a crime to not do it to the other side, so. I'm actually really happy with all those chips that came off of that. That was set up really good. Nice feed rate, everything. Beautiful looking chips. This is the machine side that's going to fit against this, go in this orientation. Fits on the bearing. Don't see a gap there, so it looks like it's clearing this snap ring as well. Everything looks good. Those holes look like they line up. These bolt holes here. Those bolt holes look like they line up. I think. So yeah, I would say that's probably what I want. Alright, next I want to put the L piece on here so it can bolt down to this mount right here on the belt sander. Be like that. Which will be this piece. Will sit in there like that. Replicate how that went. So now I'm just going to pop this in the milling machine and we'll mill off all the corners, make them look all pretty, and then we'll start drilling some holes in it because I'm actually going to bolt this thing together instead of weld it all together. My next step is bolting this piece down to this piece. Originally I was going to use these flathead taper socket thingies. I don't know what the exact name of these are. I was just going to have those coming from back side, that way they'd be nice and recessed. But unfortunately I didn't make this piece here quite wide enough. So if I use this style of bolt, the head is actually going to stick out past the edge of the material. It's going to, you know, overhang a little bit like that, right? It's not going to be in there like I want. So I'm going to use regular hex head bolts coming up through the back like that, which will be fine. No one will ever see it. Doesn't matter, whatever. I just wanted the nice flush look of these things. So I'm going to hop over to the mill next and we will drill 4 holes across there that don't interfere with the holes in here. So there'll be a bolt that just misses that hole, and a bolt in there, a bolt in there, and a bolt that just misses that hole. Okay, I had to move things around a little bit. I was just going to put this piece in this way and use my exact same coordinates in a row, and then I realized I can't keep it square this way when it's stuck in this way. Plus it's on one side of the vice jaws and nothing's holding over here. Blah, 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 lots of problems. So I turned it 90 degrees and just simply recalculated my coordinates, and by test fitting that, it looks like I'm in the correct place. Everything is looking good. So now I will swap over to my other drill bit, because we're going to drill and tap 4 holes across here now. Nice. So on this original upright piece, there was this little gusset here, and I do want to add a gusset into this just because I feel like relying on these 4 bolts that are going this direction and having pressure put on them this way is not really a great thing. So my original idea was to use the scrap piece I had laying here and whittle it down, but as you can see, it sticks out way too far here, way too tall. That's no problem, cut off with the bandsaw, shorten it down, but it's just a lot of work. So I was looking through my scrap pile and found this piece that is much closer. It's not going to be flush with this front edge here, but you know what? This gusset wasn't either, so that'll work just fine. So let's throw this in the mill and square it a little bit. I'm going to put my holes in this piece that go in the bottom of this. I'm putting 2 bolts in here. So I'm going to locate from this edge and on center, and I'm going to put 3/8 tapped holes, 1 there and 1 back there. This way. There we go. That works. All right, now gotta go back to that one. Ah, stupid thing. All right, hopefully this works now. Ah, get in there. There we go. Nice. Okay. So that piece goes in there. So now what I'm going to do is put it up in the vise, clamp onto that, and then we'll drill 2 holes in here and bolt it on this way. So my plan is to put it in here like so. all that good. And then we'll drive over here with the DRO again and figure out where I'm supposed to be at. Somebody keeps driving around. Filming a video here, people. Sheesh. We're going to finish out these holes. That's it. Now that should go on here. Hopefully I'm doing this all right. Those kind of line up. And these kind of line up. Alright. It's a thing of beauty, isn't it? How nice is that? Yeah, I got way too many hours in this, but heck, that was fun. Even though I'm falling behind on work for customers. So if you ordered something from me lately and it's a little late, sorry, it's because I was building this overly machined part. I decided I'm going to go ahead and glue these parts because, well, I don't want them to rust after I spent way too many hours machining on these things, right? So I'm going to take this all apart and we'll go outside and set up my quench tank and, well, heat these up until they're nice and blue and quench them. And hopefully it all goes well. So I'm going to clean all these parts off with mineral spirits here before I dunk them. Probably shouldn't be touching with my fingers because my fingers probably have oil all over them at this point. So we're going to get them good and clean. Any oils that are on the part will actually create a weird little pattern. So got to make sure they're good and clean. I also have to heat it with my little plumber's torch because I am out of oxygen in my regular, you know, Oxa propane torch. Woo! I'm excited about that. I want to see what that came out like. Oh man, that looks awesome. Well, I think it turned out pretty darn nice. So yeah, I'm not putting the belt guard back on because it's broken. It's just not going to happen. I'm going to try to make something for it one of these days, but I never work on this side of the belt sander. Literally never do. I always stand over here. So I probably won't get hung up in that. Famous last words. Anyway, yeah. So I'll take care of that eventually. But not today. So let's see if this thing fires up, see if it goes around. I guess that ends the video. There were several things on this adventure that I didn't show, such as replacing this bearing in this roller on this side and some other milling operations and stuff that I had to do. But this video got way too long and I felt like that stuff really didn't matter to this story. I have at least 12 hours of build time into this dang mount, which means if I was going to charge a customer, that would be $1,200. So that's a pretty pricey mount right there. But building this mount was definitely worth it because it allowed me to get my belt sander up and running, and we do a lot of projects on the CNC plasma table that we bring over here and sand, so that's how I make a lot of my money. Also, this mount is very sturdy. I don't know how well it comes across on camera, but I think you can tell it's not wiggling. This platen is not wiggling. It's staying very sturdy. You know, the rubber feet are wiggling. With this old cast mount that was there, you know, it came from the factory, I could wiggle this platen back and forth a lot. It was very wobbly. So it is much stronger and it is much nicer to sand on here. It just feels like I have a lot more control when I'm sanding and the thing's not trying to just jump away from me. So definitely a huge improvement in operation. There's still a few things I need to do to the sander. One being I definitely need to get a belt guard built for this. I thought working on this side I'd be okay, but if I'm sanding in circles and stuff like that, it's pretty easy to get a glove over into this area, and yeah, it wouldn't take much to get stuck in that belt and pulley, so definitely need to get a belt guard built for it. Also, this shaft is bent. If you can notice that, you can see the pulley wiggle. So I need to take care of that. I don't know if I can just straighten the end of this shaft or if I just need to build a whole new shaft for this end, this roller and all that. I'm not sure what's going to happen there. And another thing I'm thinking about doing, instead of tilting this sander up to do the blades for the Kindling Maker, I'm thinking about making a jig that goes on here, like right here, so I can sharpen the blades in this position, leave the belt sander flat, and hold the blades here. So I guess what I'm saying is I still have more stuff to do to this sander, but at this point I'm at least getting back onto the customer jobs and getting them sanded so we can get them shipped out. Alright, well, I really hope you enjoyed this video. Hopefully I didn't cut too much out and it all makes sense to you as to what I did. And yeah, I guess that's all I gotta say about that. So thanks for watching, everyone, and we'll see you all in the next one.